Okay, so it's really the concurrency and the asynchronous basically is the synchronization versus the, if you are doing it in sync, that means usually in the synchronized format, then you do one thing, then you wait until that ends, you do another thing, you wait until that ends, you do something else. And I think the real way to understand it is not to use it in coding, because then you have to be really experienced sometimes to know the purpose of it. But think of life, because every coding, everything is kind of mirroring most of the time life. It's inspired by life. So, so one way, okay, great. So one way to really think about it is like, imagine your life now, the way you do it, the way every time you interact with your thing, you're coding, while even you're coding, you are reading, you're drinking, whatever. Imagine just you have to do each step one by one. And that's what you have to know, what you are at the moment doing. At the moment, when you are programming, all of your programming, most likely, you have been doing one by one. It's like, unless in the background, your code, some of your packages you use, like are multi-processing, multi-threaded. So sometimes they use that. But if you, the codes that you use basically are doing a life, they are living, if you use them as a character, they are basically living a life of just you living in this world, doing only one thing at a time. And I always like to give it the example of a bus. If a bus takes you to take you home 1 hour, then it will take, you have to just wait 1 hour just to get home. But imagine asynchronous basically means like within that time, imagine that you call some of your friends, your house, your mother, your father, whatever, and then you basically can read. So imagine the amount of gain you have. Or when you fly, actually, even the best is if you are flying to another country, imagine you are flying to the US, right? Which is basically from most African countries is like, let's say 10 hours in average, right? So imagine just you have to wait 10 hours without doing anything, without watching a TV, so that's what asynchronous is. It's trying to take advantage of it. And at first it may not sound good. I mean, it's just, yeah, because computer is fast, but it really is exactly like if you are just, talking to a person, it's fine. You don't even need to do asynchronous because it's so fast. That person is in front of you or on the phone, then it's fine, right? But if the person is like if you have to talk with a very slow connection, then you start noticing like, okay, you need to do something. And if that is not a communication through a thing, but it actually have to travel, then it gets even better and better to see like, oh, you have to do asynchronous. So the asynchronous, it's not really to train this model, that model. It's really to make your life exactly like, I mean, I cannot give you the purpose of it exactly the same as like, the best you can visualize it is if you could really see it in your life, that you have to do one by one the things you do, including, going home, attending this without being distracted and stuff like that, versus the usual way you live. So there isn't one thing, but definitely for most of the purposes, it's known that sometimes, for example, if you are talking one person, paying attention is better than distracting. So that's why in asynchronous, there's also a disadvantage. If you are doing it for a fast kind of CPU intensive computation, CPU, imagine just CPU, in this case, usually anything that is numerical computation is CPU intensive. And so it's called, if it is CPU, it's basically the same as conversation. You are making conversation. And if the conversation is fast, or if it's just whatever, anything interrupting that, it's kind of doesn't help you. So that's why in asynchronous, of course, if you do it on a CPU intensive computation, it might even slow down. But if it's just not none type of conversation or non-conversation types, then that is like, for example, the real advantage why in JavaScript asynchronous is like the cornerstone is because I think you should watch it, the second video that I recommended, which is the JavaScript browser, which shows you very clearly in a very beautiful way how it actually visualizes the internal workings of JavaScript when it's computing, so that you get a very clear idea. And you also have to start understanding the part of what is an event loop and what is a stack and a heap memory. So every time you come into this, you have two memories that you have to take into consideration, and one is a stack and the other one is a heap, right? So it is almost always, it has been, I'm confused until I really need it. I never learned it. It's like, even if I knew what it means, but it's basically just, so usually it's like only when you need it. And the stack is basically the stack. To understand the stack, you have to understand, if you had error, Python error, who has got Python error so far? Like, who has looked at their Python error? So who can tell me what that Python error, how Python managed to get all those errors? Interactive. There's no benefit in me talking. Yeah, it's like, so when you do, sometimes when you make a mistake, you can even just do it. So let me do, let me present, and I'm just gonna, my entire screen probably. Okay, so, okay, so let me get error. So this is what I was showing you. Do I have error? Or I can make error. Okay, let me do this. Let's see. I'm gonna make error. Let's say, so I get this error, right? Do you see the error?
Yeah. Yes, yes.
Okay, so how did Python print this error? What is the steps that,
Hello?
what is the traceback? Yeah, yeah, go on. Go on, elaborate.
Hello? Hello?
Yeah, go on. Is that my connection
Hello?
or your connection? So do you
Hello,
guys,
can you hear me?
yeah, now we can hear you, yeah.
Okay, so let me just give it a try. I may not be right. So
Mm-hmm.
basically, I think what Python does is it tries to. I think my connection is bad. Maybe I'll just stop.
It's okay, go on, we're hearing you.
Hello? Hello? Okay, let me just give it a try. I don't know, I might be wrong. So I think what Python does is when you give it a code, it tries to run the stuff from top to the end. So basically, let's say for instance now, you are printing something and it's not in a hello. Let's say for instance now you want to print something and it's not in inverted it's maybe it's not really like a string format and you want to print it. So basically Python tries to run the code from top to bottom. And then when it cites a particular code that is not really properly formatted, let's say for instance, you are trying to do arithmetic operations on two strings. So what Python will do is Python will try to look at, okay, are this type equal? Can I actually perform any arithmetic operation on this kind of type? If it says no, then it just bring an error, like, okay, I can't actually perform this thing. Maybe the type is actually bad or something like that. So I think that's what Python does. I don't know if I'm wrong.
I mean, it's not wrong, but it doesn't answer the question. But event handling, that is very true. But how does it handle the event? Try except exception handling. That is to bypass. So that is the try except usually exactly that is to bypass the kind of error. What is it? Crashes? Is it? I don't know. Ken?
Like it just stops completely. It doesn't continue. Like where it finds the error is where it stops. It doesn't continue and see if it can continue.
Yeah, but that is normally the case usually. But then the try except, for example, is trying. It allows it not to crash. So raising in Python when it raises. So if I do like some kind of like that, for example, if I just do try, right, and then if not, I can even so except I can even issue what kind of error it is, but print. Okay, we can't. So let's just even as a let's say table name, right? Table name. Let's say so if you know the F format, so table name, table is not found, and then I will raise, right? So do you know this raise, what I'm doing by this raise?
No, sir, we don't. I don't.
Okay, great. So those.
Yeah, I think what raises to do is to tell the Python interpreter not to handle the error that is it should actually result in a trace back of the error rather than just using the accept block of the code.
It's very hard to hear. It's very, very hard. So, but as okay, so control flow. Stephanie, that's true. We are controlling the flow, but so let's just do pause, right? When I don't do that, what do you expect if I don't do raise? So what would be the output of this cell? Just Patrick, you can type it because it's very hard. Fantastic. Yeah, that's correct. So if I don't raise it, like any one of you, I think that's very correct, Patrick. But so if I don't raise it, if I run this code, you know that of course the second line, this line is wrong, right? Like because we see it earlier error. Now I did some exception handling, and then I did that. What output do you expect? Exactly, it should execute the except block. That basically means the print, right? So that's just to see it. Yeah. But imagine Python, did it get on this line? Exactly. So, but what about, so did Python get there in the line, in the try, between try and except?
I think the try keyword is to tell Python that we are expecting some kind of error or some kind of unwanted output from that code. So if there is something like that, then you should go to the except block without crashing the program, something like that.
Yeah, that's very correct. Yeah. So try actually, basically is that in this thing, the try keyword, it doesn't, it's like the if condition, right? It just gets in because it's like try. That means just, it's always true. So it means it's like if condition. Imagine it's like if condition. It's just another type of if condition. Then it says, okay, it's if true. If you make if true, it means like it always gets in, right? So that means it gets it, it executes it. But then when it executes, that's where really what this thing, what I'm talking about is that it just got an error. And then it has to look at like, was there any setting that tells me to crash, or was there any setting that tells me to continue? And then in that case, if there was a try, if it is bounded by a try, it says, oh, okay, I was told not to immediately fail. Instead, I have to go to the next branch. So in memory, it's a branch. Then you go to another branch while keeping whatever you have there. You keep it in a traceback, exactly, and then you execute. But if in the next execute, if there is nothing, like which is just only print and stuff like that, or pass, then okay, that means, you know, the error, the person doesn't care about the error. You don't print, you don't do anything. Python just silently passes. But what about this? What about when I do raise? Yeah, I did. So without the raise, this was the Moodle user Y table is not found. Exactly what I did this line. Does that answer, Ada, your question? Okay. So now what about if I use it raise? What do you expect? Yeah, so when I raise, I don't want the error to be passed, which means to note, yeah, and I want exactly. So it's exactly. So if I do this, so the usual way to do is because then you can't even, now I give feedback for myself, where it could be just say like, I usually sometimes even say at like, you know, some kind of log file, which says like, which even prints, you know, line 20 or whatever, you know, it's like, or function xyz dot pi, blah, blah, right? So now if I do that, it first prints that, exactly what I find, and then given everything was stored in the traceback, so it prints all the traceback, right? But the question is, what is a traceback? Where does Python know? How did it get this traceback? Anyone?
Hello.
Yeah?
Hello.
Yeah, go on.
Okay, so I think traceback, what happened is Python tries to point you back to the first place where it encounters an error. So take for instance, you're running a program in line 2, and then the same line 2, you're still using the output of line 2 in line 5. What will happen is that if Python encounters any error in line 2, it will tell you that the error is happening at line 2, even if the output of line 2 is given in line 5. So basically, there will be an error in line 2, and there's also an error in line 5. And then the traceback is now like, okay, this is where this error is originating from, which is line 2. I think
How
that's
does it know?
what I know about it.
The question is, yes, that's true. It, of course, is that one, but how does it know? Sure, that's also true, but how does it know? How does it keep? How does it know to print all that? Where does it get the information? How does it keep it internally? To tell you, like, imagine.
I think
Look at
it
this.
got that from the Python library. So it expects some kind of error. So when they occur, it knows which one to target from the traceback and print it.
Yeah, but that's true. But that's, I mean, the answer is really nicely given as memory stack. Probably for some of you, it's not the heap, it's actually the stack. Why? Why it's a stack? So I mean, if you look at the JavaScript second video I sent, that's really where stack, and I'm gonna play it because it's maybe, or I will just search it. So Python stack and event loop. Okay, and then let's say just in the images, just to see. Okay, so this is the one. I think this is probably the better one. Okay, so there is a heap. I mean, this is JavaScript, unfortunately, but it's probably the same.
Please, can you make it? Can you extend it?
I will
It's very
extend it.
small.
Okay, I will extend. I will just want to find probably this. So this is again JavaScript. I'm going to search it. Okay. Okay, so it's probably not this way. Okay. So probably, can I just, okay. Okay, so do you see this? Right? Hello?
Yes, we do, sir.
Yes, yes.
Okay. So where is it? Okay. So whenever in a stack, every function call, even in a normal serial computing, that means asynchronous computing, then you're running this thing, right? So this call, function call, just basically it's not called, so it's fine. It's not kind of it's just only a function definition. Is not going to be in a stack. It's just the Python interpreter, when it interprets your code, it just passes. Let's say this is Python, even if it's JS, then it goes, no, it's function definition. But then there is a point which arrives like where my mouse is, it basically in the cursor, where my cursor is, then it arrives there where actually the real start of computation starts. So that's why then you get the print square. So that's basically main. The main function is the first. This is a main. When you run a main, that's why it's a main. But then next to the main in the stack will be just the first score, print. But in the print square 4, there is another thing. So if you look at print square calls a function called a square. So that function, a stack it stacks the function that are called. Square is called. And then in the square, then just to run that line, I'm just talking about the first line. What is necessary to run the first line? First the main, then print square, then square. Then square also calls multiply, then multiply. There is nothing else. After multiply, it's just variables. The stack contains the functions that are necessary. Now imagine that error happens here. Let's say B is a string. What does it do? It just basically, because it has this stack, basically it gives you all the stack, the lines that these were defined are also in the source code. So it gets the stack, and then you have the source code. So it basically prints then this. So it goes like, oh, function this, in function this was the line. So it prints a few lines, 2 lines up and down. And then in function this, like that. So this is the stack that you get, okay? So when you read, so these are all the stacks that to just execute a line somewhere, usually it's printed at the end or like somewhere, like in my line, this part, to just execute that. Sorry? So
please, can you go over the stack and everything?
Yeah. So the stack basically is just to execute this line while it's executing this line. Okay. This is the function get data, and get data is called, if you look at search it, it's somewhere, it's in the DB manager. You know, you look at it, the very first stack is just, it's inverting it, but this was here. It all about was while trying to compute this line, okay? It starts, all the stack that you get is start everything that was necessary to execute this line, because error was in that line. And then this line was calling a function called DB manager. In it, what it's calling is inside the DB manager, inside that there is a function called get data. Inside that get data, there is a line that it was computing. It's called PSQL read SQL some queue. So, and then because read SQL is in SQL, if you just look at it, the function, and it goes into that and it prints also the line that was actually that the error occurs. And inside that function, which was read SQL, there was read query. And in the read query, there was also the line that was responsible, and then in the execute and whatever. So it's basically, this is exactly the stack. If it was this function, it's basically it's inverting it and giving you. So that means it doesn't print the main in that case, but it tells you print here. This stack basically means just this line. So this line, and then this square basically becomes the DB manager get data, and then this multiply basically becomes the read SQL. And then because this is more, it needed more stack to execute that line. So stacks basically are stacks of functions. So until the very variable that only just goes to the CPU. So until that point, it's just only function calls, but that functions can be in the library, in the actual Python code, like in the Python like internal library. It could be an external library, it could be your own code, just like all those function stacks, okay? And that's what it does. So this is a serial computing, because then when it computes, then it finishes this, then it finishes this, then it finishes that, it finishes that. And only when that finishes, then the program is done. And then it knows the program is done, it quits, okay? So it stacks first all the function calls, and it starts computing in the reverse way. Starting from the top, it's like a queue. Just, is that clear? A heap memory is on the other side. I think there is heap. So the heap memory, on the other hand, this is a structured order, while heap memory is a computing, like whatever. For example, n times n. Okay, get a memory somewhere and kind of just use it and scratch it, you know, search it. So it's kind of, it's really random access.
Hello?
Yeah. Yeah. Okay, I think your network is quite delayed. That's why it's harder. Maybe if you type it, I can read it. Okay. Okay, so I see that. So yeah, it's like a stack memory. It's basically, you can add stacks, and stacks is everything like that, right? If you are ordering something, so you can have, you know, a row of stack. It's like deck stack or whatever, like including, you know, all this is just a stack, because if you are just need to layer something, that's what is called stack. In this case, the stack trace is basically just the trace of this, like what we just shown. But the stack memory, or it's basically considered it's an event queue. So it's a queue. Just anything that you do queue, even a functional, it could be a hardware, it could be just software based. So I hope that kind of answers. And so the reason why I'm going there is that because when you do stacks, like everything in the stack now, you saw it in Python, right? So so here it was all computing it line by line, stack by stack, or like, you know, from the bottom. And if you want to compute now asynchronously, what you're going to do is that you need to find a way to kind of take it from the stack. So let's say this was a call for downloading data from a database, calling a database data. And maybe let's say the database is somewhere and it takes, let's say in the computer time, it's like taking a bus, right? Just in a human time, it would be just going by bus to home, right? Or, and in that time, if you were just in a stack, if you are in the stack, then it has to be computed for the computer to finish, to switch attention. And therefore, that's where asynchronous is coming. Asynchronous is coming because then all of, if that function that you called is called in Python is asynchio, it has it's a function that's defined by asynchio, then that asynchio basically takes this one and puts it into another memory where it actually just kind of is processed by a C++ code that basically, in this case, if it is a JavaScript, that would be like some of the external codes that are written. Python itself or JavaScripts themselves are written in such a way that they only operate on one thread, okay? But others, like the C++, for example, doesn't care. You can write anything in C++ to be multi-threaded. So, and so it calls some of the operating system functions that are required. For example, some of the operating system or even the Python or C++ codes that handles sockets, for example, because you are now database connection. You call those ones, they operate under a different thread, and then while the main thread which you are running goes. So this one is just given, and then it goes into the event loop. So the event loop basically is controlling what, like this kind of the cycle of how things are computed. And when it's finished, when this one comes, for example, when it arrives to this queue, and when there is empty, it then goes to the, basically it goes to the stack again. And then because the result is already fetched, then it gets faster. And then basically the stack completes its cycle, right? So that is the real visualization of this. You can see it in the tutorial that was given. But what really does, like in this, the Python asynchio is basically trying to help you remove one of them that normally takes time. If it's like, a request from Twitter, next week you're going to do some Twitter thing, you're requesting, while Twitter is processing and giving you, you can use that time to do something else. So, and that is really the kind of the heart of asynchio. And just basically in Python, what you need to do is that you need to define your function to be asynchio definition with asynchio definition. So that's basically I'm just gonna courses. So basically, if you define your function to be like that, async, and then you are waiting something with await, that basically turns these two definitions. Awaits is basically like sleep, but it kind of puts it into it removes it from stack and puts it into to be computed with a different thread, such that it gets back to whenever in this case, for example, whenever this computation is finished, it gets back to another, to the main thread that is computing. And that's what basically just, it's you just define slightly different with async, and then you await. So that's the two words that you need to know. You need to just await the output. And I'm not going to go in detail for this one, but that's like the main idea. I'm going to switch back now to thing. I know this is not a big introduction, but it tells you, like, if you want to compute, if you want to use asynchio computation. So multi-threading, exactly. That's how you do it, multi-threading in Python. Just that's exactly what multi-threading. So the one part I didn't define is that multi-threading is very different from multi-processing. Okay, so multi-processing is, so this one is thread. So you have one thread and they are sharing the same memory. So when you say thread, you're basically saying, like, you have one process, which is a parent, and within it, there are a number of threads. And that threads, Python itself, because of its some concept, like it locks main thread. No one is running while one line is being executed. No one is running while the stack is full. So it's just a single thread in that sense. But then multi-process means you are actually running Python in multiple, like in memory, in different types, in different isolations of memory. So you have, like, basically you have, it's kind of real multiprocessing is that one. That means you're actually isolating it as if it can be two computers far apart. It could be from Kenya and Nigeria, two computers, right? So you can do multiprocessing because it's just basically, it's going to be slow because you have to use TCP connection, but multiprocessing is very similar, just like that. So you have to use some kind of, internally there will be, you have to manage how these two processes are communicating. Those two processes can live in the same computer, but they can live in different computers. They can live even in the internet. So you can do multiprocessing in the internet. While multi-threading is, there is no shuttling, there is no fetching of data from here to here. The process manages the memory space, and you are basically only threads which ones they access. That's why two threads can access the same spot. And so that when you say like there is a thread, fight, what you're basically saying is because one probably is just writing before the other one reads and stuff. And that's why there is a thread problem if you are just doing only with thread computing. But Python made it easier using this asynchio and await. It kind of manages for you the kind of the order of the different threads connecting to each other. But multiprocessing is if you really want to expand multi-computer programming, even in one computer, you can do multiprocessing. But it's an advantage is that if you have if it's like intensive, it's usually multi-threading is that if you really know that you cannot, if you have multiple computers, that's the real advantage where you have multi-threading. And if you have a lot of fetching data, multi-threading is where you have to use. And multi-threading, to change your program into multi-threading, it's really not that hard. You just have to define await and async, okay? So multi-processing can run on a single thread. No, multi-processing is that it manages its own thread pools. So it's basically just, it is completely different to Python's, call it. Yeah, I think multi-threading is concurrent programming, yeah. But all of them are within Python. You can, sometimes it's a terminology. Concurrent is actually a bigger term that takes both multi-threading and so parallelism, actually, sorry. Parallelism is a bigger term that is applied for both multi-threading and multiprocessing. But the difference between multi-threading and multiprocessing is that multiprocessing assumes you have two Python instances running, while multi-threading is one Python, but it kind of manages internally using a loop. So that's the event loop, what we call. So the loop just manages basically a single loop, which is running on one thread.
Hello.
Yeah, go on. Ilakura? But your connection is, so that's why. Maybe it's easier.
Okay, so what's the advantage of multiprocessing over multi-threading?
So multiprocessing, you can basically, you are independent. So basically anything that requires, if you have two processors, and you can run independent things with them and it doesn't interfere. So it's basically completely parallel. So you can gain twice the speed with multiprocessing. While with multi-threading, you won't, because you are stopping one and executing another. And so it's because of that stopping, normally you don't gain as much as multiprocessing. But multi-threading, when you have actually, just like, going, exactly earlier I was explaining, if you are going home in a bus, inside the bus, you can read a book, and then you can call a friend, and you gain a lot just while you are still accomplishing one task. While multiprocessing is basically means like, you are two people, and two people basically, if you are using the same, the unfortunate thing with multiprocessing would be like, if you have to use the same tool, let's say you have only one computer, there are two people using two computers, using one computer. Then with multiprocessing, this is multiprocessing because the two people are kind of two processes, and the computer is one resource. So in that case, it's slow. While multi-threading is going to be like one person kind of in their own computation, they're kind of changing exactly as I said earlier. While the computer is running something, they call their friend, and that is called multi-threading. So one person doing multiple things at concurrently, that is multi-threading. So I hope that explains. So multiprocessing becomes very good and the recommended way when you have more processors. And when you have, especially when you have two computers separate physically, then there is no such thing called multi-threading in that. There is only multiprocessing in that aspect, in that scenario. Okay, what is the advantage of asynchio library over multi-threading from the? It's basically it manages, yes. It's basically it gives a much more control, and it manages the multi-threading the threads much nicely. So the asynchio library in Python is starting from, I think, Python 3.4. It's the recommended way. It does a lot of good things. So yeah, it used to be with multi-threading, but with multi-threading you have to handle yourself the threads, the thread fights. But with asynchio, it does for you. It does manage. So Python became JavaScript with asynchio basically. So you can now do a lot of computation, like web computation with Python because of the asynchio. So do we have two Python instances? Yeah, you can have many Python instances running on the same system. So yeah, that's multiprocessing. Yeah, that's why sometimes if you have more process than CPUs, basically it starts slowing down because that doesn't help. So usually it's better to use threads in that case. But yeah, that answers Elakura. And in Elakura again, so by default, what does Python run? Multi-threading? No, I mean, there is no default. It's just depending on the system. Yeah, it's like, I mean, Python by default, there's no such thing. There's no default multi processing in Python, but definitely there are modules that run by default multi-threading. So including, I think, scikit, whatever they have, probably some of the methods the machine learning tools use probably have threads. Okay. Yeah. So is that clear? Anyone can unmute and ask last question.
Hello.
Yeah.
Basically, now what you're saying is with multi-processing, we have two processes running in the same system.
It can be in the same system. It can be in multiple systems. It could be in internet.
Okay.
Yeah.
So like now multi-threading is that maybe one person now, like let me say maybe you are one person using, let's say two persons are using the same account. I think is that what multi-threading is? Like two persons are using the same account. I don't know.
Yeah, two persons using the same account would be yeah. I think that's
like,
multi-threading.
Hello.
Two persons using the same account is multi-threading. Yeah.
Okay. And also, please, can you go over the stacking with regards to error? Because I think my network was really bad. Like when you were saying something like, okay, this is how the error works and stuff, how the error information comes.
Because of time, I don't have time. I have to go, but you can watch it and you can raise the question in Slack because this is recorded, so you can actually go through it. And but better than me, the videos that I shared can actually explain much better because they even have visualization that make you understand this concept clearly. So that's why I shared the videos early.
Thank you.
Okay, great. So when do we need multi-threading in our challenge? I mean, right now, no. But if you are if you're slow, if your computer is getting slower to pull queries from your Postgres, you can definitely use multi-threading. So using asynchio. It's good just to have a small function that does just this, exactly like asynchio, you know, with exactly what I showed earlier. Like this part, just define a function, just a small query with async and await. Just do basic, very basic, but use multi-threading using that. So I think that's something that you could do, and it's not at all any change. You know, multi-threading, whatever. Don't fear it. It's just really simple. It just needs slightly tiny amount of detail, but nothing more. Yeah, what that would be. I think that's where we are actually, we are breaking CI/CD and kind of helping you to do integration. So code quality, you know, it really means you have to build on top of one another. So you have to have, so the CI/CD, basically the continuous integration, is that you are building, continuously integrating your code, right? So whatever, and building a product. And the continuous development, the CD part, is basically you now take that one and then you commit it in. When you commit it, let's say in GitHub, then you don't have to go and then change your deployment. It actually will take care of based on events that, you know, webhooks in Git. Then it takes from that, it then updates the deployment. So it does a lot of processes in between. So the CI/CD is just that. We are getting there. So we want everyone to get to that kind of mentality where like you kind of continuously integrate your code and continuously then develops. If it's deployed already, then it gets a deployment. As you can see, we do something like, okay, now deploy this, write code this, commit that, whatever. And in future, this is what we expect it to be, like CI/CD, a full CI/CD pipeline. Probably not within the 12 weeks, but we are trying to get there. So next week, we try to get closer by giving you the, so the question is, so would we be a project that would have the opportunity to practice CI/CD? Probably not in its full entirety, but once you have SSH access to AWS, then it's probably getting easier, because then you are deploying there and you kind of commit your code, but still there will be some parts that we cannot simulate because you may not have account yet. But it's kind of, it's aspiration, okay? Where is the test? I don't see the test. And also there's testing in DSML, just like software engineering. You mean unit tests? So unit tests, we definitely, by the end of we will have next week at least tutorials like that. So these days, the tutorials, as you can see, is just not related directly. But we are going to cover, yes, definitely unit tests. We are going to have some people that will give unit test talks. And I mean, unit tests, again, we will ask you to write in the next week, at least for one of your code to write a unit test, yeah. So it's basically a flavor we are giving you, definitely. It's not the full thing, but at least you are exposed. So you're not going to be, you know, you can always say like, oh, I've tried it, at least I have at least done one. That's better than I don't know, or I haven't tried it. So that's our plan. Great. So thanks a lot, guys. Hope you enjoyed it. Cheers.